In this video we're going to be discussing the concept of an ellipse. With an ellipse, the sum of the distances from the foci to a point on the ellipse is the same. So we're going to do a little example of that right here, and my wonderful assistant is going to put some string on the foci right there, and we'll make those two the foci. And you can do this at home if you'd like, so if you need to pause, go ahead. But basically what you want to do is you want to take your writing utensil, and you need a little bit of slack in between the two. Works best if you can get just enough like this so you can get a nice shape. And all you do while your assistant is holding that down is just move your writing utensil back and forth, and making sure that this distance here doesn't change, or at least the sum of the distances doesn't change. So we can do the same thing on this side. And as we move around, you should get something very close to an ellipse. And if we did this perfectly, these ends would match up, and these ends would match up here. Now it's important to note that the foci are in between, or they're inside of the ellipse. Now I tried this the other day, and I did this perfectly. I know it's hard to believe, but here's what mine looks like when I did it on my own. I took some time to prepare, did a little meditation beforehand, and you can see how perfect this is. So what I'd like to do is discuss some of the parts of the ellipse right now with you. So there's one part, or one point I should say, that is of a central concept to an ellipse, and that would be the center. So if we start to label these points here, we've got the foci here, or each one is called a focus. And then the center is going to be right here, well, right in the center, kind of like a circle. Matter of fact, an ellipse, some of you know this as an oval. It's just a stretched circle. If you want to think about it like that, you can. There is a line that goes right through the foci and then the center. And that line is going to be called the major axis. So we'll write that over here on the side. And the major axis runs the entire width here of the ellipse, and it's the longest distance that you see between 2 points on the ellipse. So I'll make a mark here, and there is a variable we use to mean half of that, and that variable is a. You might see this worded as the semi-major axis, just because it's half of the entire major axis. Remember, the major axis is all the way across. We usually use the variable a. There's another part right here, another distance again, and this distance we use the letter C, and that's the distance from the center to either one of the foci. Where the major axis meets with the ellipse itself, those are called the vertices, or in the case of a singular, that would be a vertex. And if we take a look at the other direction, if we draw a line up and down now, in this case it would be perpendicular. It's always going to be perpendicular to the major axis. It would be a line that looks like this, passing right through the center. This we call the minor axis. So it's the shorter of the two if you're comparing the distances. So the major axis is always the biggest one. It could be horizontal, as in this case. And I think if you print the notes out at home, this is going to look maybe a little bit like this for you. So you can just turn it sideways. I hope you've done that already, and when you're writing this down. But it doesn't matter which direction it goes. It's just the major axis is the biggest one. So I mean, if we turn this up and down, now the major axis is vertical. So it can be either way. It could be horizontal or vertical. And for more fun, there are ellipses that are on a diagonal, but we will not get to that in this learning target in this video. So anyways, we've got the minor axis, and that would make this piece here, the semi-minor axis. And there's a variable that we use here, and for those of you at home looking at this, you guessed it, AC, and the one here in the middle would be B. I like to remember C as being the distance for the focus, or the foci, between the center and the foci, as the middle letter of focus, just something I kind of noticed. A is always the bigger of the three. The foci are inside of the ellipse, so if we compare the distance of A and C, A is always bigger than C, and A would be half the distance of the major axis, which is always bigger than the minor, so A is going to be the biggest one that you see here. Now where the minor axis meets the ellipse, those are some vertices as well. So we've got a vertex here and a vertex here, and you might hear these called the minor axis vertices, and then the ones that are on the major axis, those would also be called the major axis. But essentially that's what it is. Here's an ellipse. This is really all the vocabulary that you need to know. We're going to switch gears to the equation of an ellipse. So I think what I'm going to do is do that in another concept video. So look to the second concept video for some information about the equation of an ellipse.